Hi student, in this video lecture we are going to study one more concept from computer graphics, that is the snowflake. Uh, when we are considering this snowflake uh, can be generated from extend to the coach curve. So coach curve can be extended to generate the snowflake. For generation of a snowflake, we need to apply coach curve to every edges of triangle, which is shown in figure A, B and C. So this is the example for the snowflake. First we considering triangle, again extending, consider this is the coach curve, and extending this we got this, extending this B to we got this C. So by using this way we can generate the snowflakes. And the length of each edge of a triangle goes on increasing more and more roughness in number of iterations. If we zoom the particular part of the snake fork, we will come to know that it processes exactly self simultaneously property like of the fractal. So that means when we zoom the particular part of the snowflake, then we will come to know that it is the process of exactly self similarity property of the fractals. So this is all about the snowflake. The next concept is the fractal line. Fractal line. So when we're considering the fractal line, or when we want to generate the fractal line, we having the some steps. First step, if the user provide two endpoint of a line as x1, y1, z1 and x2, y2, z2, right? Then we have to find the halfway point for fractal, right? And second step, the halfway point is calculated from the midpoint of a line. So let's consider, when we're considering the halfway point. So here we're considering the simple figure like this one, or how to find the halfway point. Here we're considering the triangle, right? This is your halfway point, right? And we find out this is considered x1, y1, z1, x2, y2, z2, and this is the midpoint, that is the xm, ym, zm. So the midpoint xm, ym, zm can be calculated as xm is equal to x1 plus x2 divided by 2, ym y1 plus y2 divided by 2, and zm is equal to z1 plus z2 divided by 2. But when we having the order to achieve the halfway point, we have to add offset of each coordinate midpoint. So when we considering the offset, that is xm is equal to xn plus dx, that is x1 plus x2 plus 2 plus dx, because we having the value xm is the x1 plus x2 plus divided by 2. Similarly for ym, y1 plus y2 plus 2 plus dy. Then next zm, z1 plus z2 divided by 2 plus dou z. So here dou x, dx, dy and dz is the offset and must be the random value. At some position it may be inside, and at other position it may be opposite side, right? It may be the opposite side, that is which consider with respect to random value. So when we considering the random value, we considering the cost line like this one. So this is the cost line, and when we considering this cost line, right, we finding the random offset like dx is equal to L into W into gas, dy is equal to L into W into gas, and dz is equal to L into W into gas. So where this L is the length of segment, this W is the weight factor for roughness curve, that is the fractal dimension, and when we consider the gas, some random average value. So this can be works, or this halfway point can be divided the original line into two parts, right? Divide original line into two parts, again repeat the same process, for each part separately. So this is the your fractal line concept. Thank you.